parentheses, x in both first positions. Coming over, making my t-bar for 63. 1 times 63. 2 won't work, it's an odd number. 3, well, if I add the digits, I get 9, and 3 does go into 9, so 3 will work. 3 goes into 6 twice, and 3 goes into 3 once. That multiplication wasn't on the top of my head, but in division with really quickly with the finger division, we can easily get that done. 4 won't work, it's not even. 5 doesn't work, it doesn't end in a 0 or a 5. 6 might work, 6 goes into 6 once, but 6, well, there's a remainder. Never mind about 6. 7, 7 times 9 is 63. 8, no, nothing, 8 times 8 is 64, that's as close as I can get. And 9 I have already, so those are my factors. When you do the divisibility of numbers, that's from way back. Go back and look at those videos. You could use it again. These are pivotal skills. These are skills that you can use in a lot of different areas. I'm teaching you the basics. I don't have to teach you every little nuance of math. I need to teach you enough of the basics so you can apply it again and again to new situations. Here's another obvious use of the divisibility of numbers. Okay, we need a positive 63. The only way I can get that with multiplication is 2 negatives or 2 positives. I need a 16 when I'm all done. So this has to add or subtract to 16. And that also has to be positive. And the only way you can get a positive with an addition or subtraction is positive. They have to have the add, it has to be positive in both spots. So now I figured that out by just thinking through the rules for positive and negative. Another pivotal skill. Here it is again. Okay, now we're going to need 16. 1 and 63, that's not going to give us 16 if we add or subtract. How about this one? If we add those two together, we get a 24. If we subtract, it's 18. Ooh, close, but not it. 7 plus 9 is 16. Here we are. So our 7 and our 9. And it doesn't really matter. You could have it like that, or you could have it this way. It's still going to be fine. And if we factor back, x squared plus 7x plus 9x plus 63. In this particular problem, it didn't matter if we switched the 7 and the 9. In some instances, it does.